Hi guys, today we're starting a new unit. It's Unit 2, and the name of the unit is Transformations. So we're going to talk a little bit about transformations, what they are. We're going to go over a lot of vocabulary today, a whole lot of vocabulary, just so that when we're talking about things, you'll know exactly what it is that we're talking about. So first of all, let's talk about what a transformation is. A transformation is moving all points in a figure according to the same rules. Okay, so taking one figure, moving it to another place, but all the points in that figure get moved by the same rule. There are 4 types of transformations that we can look at: translations, reflections, rotations, and dilations. So when we're talking about figures, it's helpful to name the figures as a pre-image or an image. So when I talk about a pre-image, what I'm talking about is the original figure, okay, the figure that we started with. When I'm talking about the image, I'm talking about the new figure that is produced from a transformation. So once that figure moves or gets larger, smaller, rotates, reflects, whatever the case may be, that new figure that's formed is called the image. Well, within those, we have things called isometries. So what is an isometry? An isometry is a type of transformation that preserves the shape and the size of a figure. So an isometry is a transformation that occurs and the size and the shape of the figure doesn't change, right? So that remains the same. Really, the location is what changes. So it's important to remember that the angles and side lengths remain the same from the pre-image to the image with an isometry. So another way that some books will refer to isometries is by calling them rigid motion transformations, okay? Rigid motion transformations. So there are 3 types of rigid motion transformations. They're translations, reflections, and rotations. Okay, those are all isometries. A dilation is not an isometry. And in case you're wondering why, the reason why is because the side lengths don't remain the same length. Okay, so a dilation is not an isometry. However, translations, reflections, and rotations are in fact isometries. All right, so let's look over here. An isometry or rigid motion. So if one shape can become another using turns, flips, and or sides, then the 2 shapes are called congruent. So what we see here in this first little graph is we see a rotation occurring, okay? So our pre-image is the light pink triangle, and our image is the red. And what we see is what we call a counterclockwise rotation. Okay, notice the size and the shape of the figure did not change. The only thing that changed was its location. The next one that we see is a reflection. So the light pink would be our pre-image, and the red would be our image. So notice the light pink figure has been reflected or flipped over this red line. And then the last one that we see here is called a translation. We also sometimes will refer to that as a slide, okay? We're moving all of our points. It can be just your x values are changing, or just your y values are changing, or both your x and your y values are changing. So here the light pink triangle is our pre-image and the dark red is the image. All right, so after any of these transformations, turn, flip, or slide, the shape still has the same size, area, angles, and side lengths. Therefore, once again, just driving home the point that these are in fact isometries or rigid motions. All right, so today's lesson, we're going to really focus on something called a translation. So a translation is a slide of a figure to a new location, okay? Something important to note is that the figure doesn't change size or shape, it just simply slides, okay? So if this red figure that we have here is our pre-image and this blue figure is our image, what's happened is it's just all these points have slid up and over to the left, okay? So now let's look at these 3 figures right here. The directions say, what type of isometries are the following transformations? So if I asked you, hey guys, what does this isometry look like to you? I would hope that you would tell me that it would be any guesses? reflection. Good. And if we're looking at the red ones, what do we see happen? We would call this a translation. And then lastly, what we can see from the light orange to the dark orange here, any guesses? This would in fact be an example of a rotation. All right, so that being said, let's look into an example of how we can translate points using a rule. So oftentimes when we have translations, we'll be given a rule, okay? And what that rule does is it tells us what to do to the x value and what to do to the y value to get from our pre-image points to our image points, okay? So if we want to translate the following points using this rule, what this rule says that in order to find C prime, by the way, C prime, anytime you see the prime notation that looks like that little apostrophe right there, that tells us that we have an image point, okay? The C, because it does not contain the prime notation, would be our pre-image point. C prime then would be our image point. The prime matters. If you have done some kind of an operation, translation, rotation, reflection, to that point, you must put a prime, okay, if you're doing something. So now how do we get the C prime point or the image point? Well, what we're going to do is we're going to take -2 for this x value in C, and we're going to actually put it in for x in here. And we're going to take the y value of 4 and put it in for the y value in our rule. So when we do that, -2 plus -8 we know is -10. And we know that 4 plus 2 is in fact 6. So C prime, or our image point, is -10 comma 6. Okay, and we got that by simply using our rule. Okay, what the rule does is it tells us how to get our image point from our pre-image. All right, so let's try and find A prime. So A prime, if I take 0 and I plug it in for x in our rule, 0 minus 8 is -8. And if I plug in -8 into y for our rule, I get out -6. So that's my A prime point. And my T prime point. Once again, plugging in -3 for x in my rule, -3 minus 8 is -11. And 5 plus 2 is 7. So there you go. You have found the image C prime, A prime, T prime by using our rule. All right, so let's look at the next example. All right, you guys try this one on your own. Pause the video, and then let's come back and see if you got it right. All right, so for H, you should have gotten 3, -1. For H prime, I need to include that. For A prime, you should have gotten -1, -8. And for T prime, you should have gotten 6, -4. Okay, hopefully you did okay on that. All right, let's look at example 3. Example 3 says, find the pre-image using the rule below. All right, so this problem's kind of interesting, right? Because we're not actually looking for the image points. We actually already have those, right? We already have our image points. We have M prime, A prime, T prime. So what we're looking for is our pre-image points, M, A, and T. So how are we going to do that? Well, something that you need to think about is this. Algebraically, what is happening is this. -2, say your x value on your image point, is equal to this x value in our rule. Okay, so technically I can set up an algebraic equation that says -2 is equal to x minus 15. And I can solve this for x. So if I add 15 to each side, I get 13 is equal to x. So my x value for my pre-image is 13. If I take that same logic and I apply it to y, what that means is -3 in my image has to equal y minus 6 in the image portion of my rule. Once again, solving for y, I end up with y is equal to 3. So my pre-image point is 13, 3. Okay. Another way that you can think about it, if you don't want to consider it algebraically, is this way. If I want to find my pre-image point A, I can take 4 from my image A prime point, and I can add 15 to it, which gives me 19. I can take my y value on my image point and add 6 to it, which gives me 15. Okay, so notice we're doing the inverse operation of what we see in the rule. Lastly, looking for my t image point, 0 plus 15 is 15, and negative 2 plus 6 is 4. And there we are. All right, so let's go ahead and look at our last example for today. It says, given the pre-image, M-A-T-H, and the image, M prime, A prime, T prime, H prime, write the formula for the translation. All right, so let's look at this real quick. So we want to figure out what the formula is for this translation based on just the points that we have. So the first thing that I might do is I might actually consider my M point. My M point here I see is located at -5, 3. And I see that my M prime point is located at 3, -1. Running out of space, sorry. Okay, so now maybe let's look at our A point. Our A point here is located at -1, 3. And A prime is located at 7, -1. T point here is located at -1, -1. T prime is located at 7, -5. And lastly, your H point here is located at -5, -1. And H prime is located at 3, -5. So now what I need to do is I need to come up with some rule that is applicable or works for each one of these pre-image points, yielding the appropriate image point. So I'm going to start by saying xy such that is what the arrow means. Open a parenthesis. So now if I go back and I compare my, if I compare the my x values here in my M point, I see that I have, oh, I was hoping to highlight. Let's see here. If I can figure out how to highlight on here. No. I have -5 and 3. So what could I do to an x value to get from x equals -5 to +3? And if you're like, well, Ms. Powell, if we added 8 to -5, we would get +3. You're right. So let's look and see if that same rule holds for the other points. If I added 8 to -1, would I get +7? The answer is yes. If I added 8 to -1 for the T point, would I get would I get +7? The answer is yes. And the same thing happens with H. So that rule holds. So x plus 8, that's an 8, is that portion of my rule. Now let's consider my y's. So following the same logic, going from M to M prime, I'm starting at 3 and ending at -1. Well, if I subtracted 4 from 3, I would get -1. So let's see if that rule holds true for the rest. In the A point, 3 minus 4 is -1. Same thing with T, -1 minus 4 is -5. Therefore, what we can see here is that y minus 4 is the y portion of the rule for the image. So I hope that's helpful, and I hope you guys have a great day, and we will see you soon.